name is Rainer Buchholz. I am the president and owner of Renia GmbH, Renia Adhesives, based in Cologne, Germany. Renia was founded in 1930 by my great-grandfather, so I'm the fourth generation. Since 2018, I've been the sole president and sole owner of this corporation. Renia is one part of the business. The other part we acquired in 2018 is called Zima Adhesives. Zima is more focused on shoe industry, while Renia is a company that mainly deals with shoe repair, orthopedics, pedorthics, some prosthetic applications, a little bit in toy manufacturing, a lot of leather crafting, a lot of bespoke shoemaking, but the industry side is covered by Zima. We have one factory in Cologne, in a very green area, so we are probably the only chemical manufacturer in an environmental protected zone in Germany, but we were here first, so they built this around us. It's a relatively small company. We have 30 employees in total. We also have a distribution warehouse for our US customers in Norcross in Georgia, which is close to Atlanta, but that is just distribution, no manufacturing. All development, all manufacturing takes place in Cologne, Germany at this location here. We produce around 700 tons of adhesives per year. That is the solvent-based side. Water-based adhesives we produce around 30 tons per year. So now, Renia adhesives were at first produced mainly for shoe repair. Shoe repair was a much larger market. I'm sure you're aware of this. Back in the 1950s, just to talk about one number here, Germany had around 50,000 shoe repair shops. Now, if it's 3,000, that's a lot, and that's counting everything related. That's counting orthopedics, that's counting a few bespoke shoemakers, and that's counting fast repair shops and shopping malls. But it's not nearly as large as it was. So we had to branch out into other industries, starting in the 1960s, 1970s. The first of those were the orthopedics industry, insole manufacturing, bespoke orthopedic shoemaking, which has different challenges compared to a fashionable shoe, especially as far as the last is concerned. You're basically treating a patient. You're not fitting a shoe to a healthy foot, but you're treating a sick foot. And you have the associated challenges with that. We have more recently started to branch out into saddlery. Also not so much manufacturing, but also repair and smaller saddle shops. We work with bespoke shoemakers, or we manufacture products for bespoke shoemakers. We have larger presence in leather crafting nowadays, which is more of a hobby market, but that is what the products are made for. Basically, we offer the full lineup, anything you need. So for soling, if we're talking about leather construction, the most well-suited adhesive would be our Renia Top Fit, which also works on wet leather. So if we're talking about molded soles like cowboy boots, for instance, wet molded soles, it is also highly suitable for that. It is highly suitable for hidden channel stitching, so that you can fold down the channel while the leather is still wet. With this adhesive, no problem at all. We also recently added a cork bottom filler, which is solvent-based. If we're looking at synthetic shoes, synthetic soles, which is becoming more and more common, cup soles, thermoplastic rubber, different rubber types, which in some cases need to be pre-treated chemically anyway. Our most versatile product for this is the Cologne. For upper construction, we offer our classic rubber cement, rubber solution, which is basically natural rubber dissolved in solvent. We also replicate this entire program without solvents. We also offer similar products in the water-based range, namely our Aqualim 315 and Aqualim 130 for soling, and Aqualim GL, Aqualim SG, and also 315 for upper construction and lasting. Every batch that goes out is tested. In this case, it means it's tested for viscosity, it's tested for solid content, and that tells us if it's within those specifications, then we put everything in that's supposed to go in there. Certain products are also tested every batch for their bonding properties, because they're a bit more complicated to make So it is necessary to make sure that everything went right in the production process. Also others are tested intermittently, not every batch, but we still make sure that everything works. This is done with the standardized testing materials that we get from certified suppliers. Standard width, standard length, standard pretreatment. They're tested in a pull testing machine, so the materials are bonded. You wait for 24 hours, they're split bit by bit to test for the actual bonding strength of the adhesive. Longevity tests, or actually aging tests, that's also something we do. Of course, you can just produce a batch and you can leave that batch on the shelf for 12 months and then you know what it does after 12 months. But do we have that kind of time? Of course, no, we don't. So what we can do is we use a heat cabinet, and if you heat chemicals and also adhesives, you accelerate the aging process. So after 6 weeks, we can tell what would have otherwise happened after 12 months. So this saves a little bit of time, and it's also done intermittently on batches that we produce, just to make sure that everything has been done correctly. Now generally, the chemicals in there are the same. The materials involved are pretty much the same that you're trying to bond, so the adhesives also have to be very similar, but there's differences. Industry customers work in a different way. As a bespoke shoemaker, you use a grinder, you use different materials. Industry likes to work with cups holes a lot, with injection molding a lot. They use sophisticated lasting machines for the toes and the heels, and that's not something that is usually found in a shoemaker shop. So the products that are used have to be adapted to that. Industry customers require primers for everything. Everything is primed, double coated, then they let it dry completely, then they reheat it, then they join it under pressure, then in some cases there's cooling tunnels involved, so it's a highly technical process. Shoe industry also likes using hot melts in certain applications, such as for those lasting machines. Whereas a bespoke shoemaker would use a rubber cement, rubber solution for that, or a corresponding water-based adhesive. Many processes are the same. Soling, for instance, of course, you also use a sole press. I don't think you'll find an industry factory that will hammer their soles on or manually peg them as cowboy boot makers do. So certain processes demand special products, and that's basically what it comes down to, which is why we have the two separate lines: Zima adhesives for industry, Renia adhesives for a trade bespoke environment. It is what it says on the can. It's a solution of natural rubber. A long, long time ago, every shoemaker made this himself. You had rubber shavings, natural rubber shavings, and you put that, or your forefathers put that in a glass or in a jar or can filled with benzene or other crazily hazardous solvents, and it would dissolve over a few hours, a few days, and then they had their own rubber solution. Very easy to make, not a very safe thing to do, which is one reason why it's not done like that anymore. We use natural rubber, which is basically plantation rubber, plantation crepe. We dissolve that in a certain solvent combination, and then it's shipped out ready to go. So this is basically a weak contact adhesive. Contact adhesive is a separate point here, but rubber cement, rubber solution is also based on its use. It is a contact adhesive. Contact means you coat both sides, you let it dry, you heat it, whatever you want to do, you bring it in contact, and then you get a bond. That's contact adhesive in a nutshell. So you do the same with a rubber solution. Why is it not called a contact adhesive? Usually because it is a pretty weak one. It doesn't give you a permanent bond usually. It does on certain materials, it depends a little bit. But bonds made with rubber solution are usually stitched through. So why is it used for that? First of all, it allows some adjustability, so you can peel back the material, stick it back down without damaging it. And also it doesn't stick to the needle, it doesn't stick to the thread when you sew it. You can provide more or less within certain limitations. More or less every adhesive discussed here in a water-based form. It's a little different chemically. The raw materials are not strictly the same. They're the same basic raw materials. They do more or less the same. There are some limitations in application, but you can replicate pretty much anything that we do with solvents. We can replicate that with water. So we have water-based contact cements, we have water-based sort of rubber solution. This all exists. Now there's also other products like the already mentioned Hirschkleber, which is a starch paste. This is also water-based, it doesn't contain any solvents, but this has an entirely different purpose. It is also an adhesive. Similar adhesive products are used, for instance, for paper bonding. So the tobacco industry, the cigarette industry uses these products to bond cigarette paper. But in this case, what we're interested in, these products stiffen as they dry or as they cure. So it is used for making toe boxes, for bonding in heel counters, because if you bond it in this way, then the materials will stiffen over time, and then you have a stiff toe box or a stiff heel, which is what you want in this case. Contact adhesives in most cases are based on one of two classes of raw materials. One option would be polyurethane. Polyurethane-based adhesives are used very, very often in shoe industry. This is another difference between bespoke shoemaking and shoe industry. Shoe industry mainly works based on polyurethane, which needs to be activated, which needs a lot of pressure, but which bonds very well to those synthetics. The other option would be polychloroprene or CR. You probably know that as neoprene, although I have to be a little careful with that name because neoprene is a trademark of the US-based DuPont company. So the chemical name is polychloroprene, but most people know it as neoprene because neoprene was the first material of this kind. Neoprene resins, certain additives, adhesion promoters, of course, lots of solvents in different combinations, and that's what makes the contact adhesive. Like I said, it also exists in a water-based form with basically the same materials. You have your neoprene, you have your resins, you have your adhesion promoters, additives, whatever. Each of them has their place. So I'm not a shoemaker, but even I know that I wouldn't use, for instance, Hirschkleber or rubber solution to attach a shoe sole. That makes no sense. For that, I would use a contact cement. Unless you're sewing and you're bonding leather, then you can get away with rubber solution. It's possible, but there's different applications. So that is the reason to use a particular product in a particular place, because that process is most well suited to that particular product. Rubber solution mostly for uppers, for lasting, craft paste or Hirschkleber, if it refers to that, for toes and heel counters, and contact adhesives mostly for soling, but also for some upper construction. If you want to bond leather to leather or leather to rubber, I can easily recommend our Top Fit, which is probably the strongest contact adhesive for that purpose. As soon as PVC, vinyl, thermoplastic rubber, polyurethane get involved, I would immediately switch to a Cologne or Synthetic Total, which is a polyurethane-based adhesive. Cologne is neoprene-based, but especially modified neoprene in order to work on those synthetic materials. Thermoplastic rubber, the best adhesive, doesn't do anything for you without using the correct primer. In this case, it's necessary, whether you're manufacturing or doing bespoke work. So it really, really depends on what you're doing, what materials you're working with. Use Aquilin, very easy. Water-based adhesive. Many smaller makers don't have a big workshop, don't have proper fume extraction. Some work from their own home, in the basement, in the garage, whatever. And particularly in this case, yes, solvent-based adhesives are safe to use if you use them the right way, but such an environment can actually preclude you from doing that. You might be exposed to more solvents than you want to expose yourself to. So in that case, water-based adhesives are the better option, but they are not able to really do everything. Top Fit. Easy answer, that's all I can say to that. Rubber solution. Renia makes a rubber solution called Renia Gummilösung or rubber solution. Aqualim SG is a special pressure-sensitive adhesive based on PVA, polyvinyl acetate, which is completely non-permanent. Never cures, it always remains sticky. So if you use it for anything, you want it non-permanent. You want to sew it to actually keep it there. And it works one-sided, which is also an interesting application here. Now, moving can mean two things. If you want to peel it, rubber solution, Aqualim SG. If you want to slide it, that's a more difficult topic here, because even those adhesives, they're not, once they're properly dry, they stick and they prevent sliding, which is their function. So if you want to slide anything, like for instance sliding a sock or an insole into the shoe bottom, you can do this, but in this case you have to work wet. So the adhesive still has to be liquid on the surface. Then you can slide it in, press it down, but this also means you have a much longer drying time compared to drying it on the surface. Very easy explanation, because the solvents or the water have to evaporate through the material and cannot evaporate straight into the air. Any solvent-based adhesive, no matter who manufactures it, is hazardous by definition. So these products always come with a material safety data sheet, or MSDS, which details the dangers involved, which deals protective measures you can take. For instance, make sure there's no electrostatic discharges or no open flames when you work with the adhesive. Very simple, you would have probably known that already. So this is applicable to every solvent-based adhesive out there to varying degrees. Why do I say that? Because there's still many contact adhesives on the market that contain products such as toluene, such as MEK, which are less hazardous than what was used in the 1950s, but which, in my opinion, don't really have a place, especially toluene, in today's market and today's industry, because there's easy replacements for them and they are especially dangerous. Toluene is harmful to the fetus, harmful to unborn children. You can very easily get that information, just look at the MSDS and work according to what is provided in the safety data sheet. The safety data sheet is a very valuable source of information, not just for the hazards, not just for the chemicals that are in there, but also how to mediate the hazards and how to make sure that you don't have a problem. There's safe exposure limits in there for all the chemicals involved, also according to where you are. If you are above those exposure limits, which are basically so and so many milligrams per cubic meter of air, the easiest way to bring that down is to use a fume extraction system, a ventilation system, because that simply increases the amount of air that is cycled through your workspace and therefore the concentration goes down. Water-based adhesives are an easy answer to that. They don't contain solvents. They are, I would say, as non-toxic as an adhesive can be. I have to be very careful with that word, because there can be, for instance, there can be an allergic reaction to something that is contained in the product, and that's possible with any chemical or consumer product. The adhesive content in a pair of shoes is so small that the environmental impact is also minimal. There are regulations, for instance, about solvent content per pair of shoes. That is limited, although there are so many exceptions that there's always ways around that. And the easiest way around that for large manufacturers is to actually manufacture somewhere else. We increase our environmental standards, we increase our safety standards, and the result is we still get the same products manufactured under even worse conditions somewhere else. Most of the raw materials we use are oil-based, coal-based, generally fossil-based. There are some manufacturers that have started marketing so-called sustainable materials made from plants, made from animal products, whatever. But currently they have not reached the technical level that the products have that we are used to. What complicates this even further is the very long and involved supply chain in the chemical industry. They're not just 2 or 3 steps, there's in some products 15, 20 steps from the base raw material, oil, coal, whatever, or minerals, to the final product that we're using, and then there's a couple more steps until it reaches you. So you can calculate the impact in all these regards, yes, but it is an extremely complicated and expensive process. You don't have all the information. There are some general files on this, environmental footprint, carbon footprint, whatever, but they're so generalized that they're almost useless. What has to be kept in mind here though is how much adhesive is used in a pair of shoes. So I think we are safe to say that the impact from the adhesive in these regards is pretty much negligible. Some of them, yes, they are harmful to the environment, but it really depends. How would you cause that harm? Of course, you shouldn't pour adhesive that you don't need anymore into the sink. What about evaporation though? Because the solvents, in case of solvent-based adhesives, the solvents evaporate and they go up into the air. What happens with those is that once they're exposed to sunlight, to UV light, they're broken down into basic components, into more basic molecules. So after you vent the solvent-laden air out of your workshop, within the next minutes, hours, those solvents will turn basically into carbon dioxide and water. And well, water doesn't do anything in this case, and carbon dioxide is not a toxic gas. So evaporation is not an issue. What we have to worry about with solvent evaporation is workplace safety and, of course, concentrations. If these materials reach animals, plants, or whatever in high concentration before they can be broken down, of course, that can be an issue. But this is more of a shoe industry question, or actually more of a chemical production question, air exhaust treatment, fume treatment, but we don't even have to do this in our factory, and we deal with a lot more solvent, obviously, than and of course, the easiest way, use aqua. Use water-based adhesives, because they don't contain solvents. There are, of course, big forces pushing the chemical industry as a whole towards a more greener approach, and the industry is following that because they have to, but we really have to be careful here. Of course, for instance, using resins based on plants, using processes that use less energy, I don't have a problem with that. Wonderful, yeah? Bring it on, bring those materials on, let us work with them. Large-scale manufacturing has largely shifted to water-based dispersions, that is true, but as far as repair and bespoke making is concerned, most are still using solvent-based. And also some smaller manufacturers and manufacturers for certain applications. There is a big push towards sustainability, towards more sustainable materials. Again, I agree with that, but tell it to us like it is, speaking to the industry here, and make stuff repairable. There is a huge push towards that in electronics, in many other consumer articles, but not yet in shoes, and we need that. We're mostly concerned with how to bond certain new materials, especially recycled materials, which can pose a unique challenge. I don't think any shoe of any construction that is sold for 10 pounds, 20 pounds, or euros, whatever, dollars, can be made in a sustainable way. Does the shoe industry have an interest in that? I don't think they do, because they want to sell more. And if they can, along with this, sell a good conscience to the consumer. Yes, I'm buying 20 pairs of shoes a year for 20 pounds each, but yeah, they're recyclable, so it's fine. No, I'm sorry, it's not. So yes, there is a possibility towards that goal, but it would involve a huge shift in consumer behavior, moving shoes, or the perception of shoes and fashion and clothing from a consumed article, from something that is worn and discarded, to an investment and to something you take care of and that you make sure that you can actually wear it for a long time and use it for a long time. Maybe we can all contribute a little bit to that.